Designed watch hands in the Fusion, switch to manufacturing mode, create new setup, and select the machine this created for GRBL. Then we select milling, define the origin. It can be defined from the model or from the arbitrary point. Select the model which would be cut. Then we defined dimensions of the stock. It is fixed sized box. Width and depth we position from the center, and the height we position from the top of the stock. Thickness of the razor blade is 0.1 millimeter. Then we select offset as 1 and default name of the program 1. Then we create the first operation. It would be 2D contour operation. It is pretty simple. Select the tool. I preliminarily created several tools. This is 0.3 millimeter flat end mill. Then we override the default speed of the tool. It is different operations, and transitions have higher speed, but the cut is just 10 millimeter per minute. Then we select the cutting contour. Select the contour, and the arrow shows it is internal cut. Then we select the heights of the tool within different stages. The bottom height is below of the bottom on 0.2 millimeter, and the top height above the contour on the 0.025 millimeter, and then different retract heights. We use multiple depth. It is several passes, and each pass is 0.05 millimeter, including finishing pass. And then we can check how it would go with the simulation. We can also use this info tab to check different operations and the feed rate for the particular operation and the position if it's needed. So finishing cutting is 10 millimeter per minute. It's pretty slow, but because we have pretty small models, it's okay. Give it a name to the operation, and then we can save G-code file. Choose the machine folder where this G-code file would be saved. Select the initial position of the tool. It is 0 for X, Y, and 5 millimeters for the Z. Then we put the name for the file and click Save. Ignore this warning. Then we can create another operation as new or as a duplicate of the existing one. And then we just change the name and the contour. Clean the previous contour and select the new one. All other settings remain the same. Check this with the simulation. This internal cut is wider than the previous one. It's 0.8 millimeters, so we can select the larger tool. And so we can select 0.5 and we can check how it can be configured. In the cutter tab, you can define the diameter of the cutter, shaft diameter, different lengths, and just follow the picture. And then we also can select the type. This one is flat end mill. You can select another types, amount of fluids in the material. This particularly is carbide tool. No shaft, no holders settings. Then we can define default cutting data like feeds, feed rates for different operations, which can be written later on. In post-processor we keep this manual tool change. Select the tool and turn off the coolant because it's not used. This arrow shows that this is internal cut. Then we can save it as a G-code file with the same start position, machine and post-processor for GRBL. Ignore the warning and create another operation. So duplicate also need to be renamed, and we need to change the contour. So it's pretty similar. Double check with the simulation. Then save it as a G-code file. New operation for another hole. Save it as G-code. And now we need to create operation to cut away all this so remove the old contour and select the outer contour. So if you look at the simulation, several passes cut the entire hand, so it would flew away. We can fix it with adding the tabs. Tabs would connect the hand to the stock. So a couple first passes would go through, but the other passes would just skip these places for the tabs. You can define it manually or you can define it automatically. You can define dimensions of tabs and height of the tabs. Let's see how it looks in the simulation. The first couple tabs just go along, but then tabs would be jumped over. New operation as the copy of the last operation, and just repeat changing the contour and rearranging the tabs. Clean previous tabs and defined new tabs manually. Unfortunately, I didn't put the correct exact position when I cut it, so the tool would cut away those tabs. We will not see it. Saving in G-code file. So individual G-code file for each operation allows to stop it, repeat it, and select the operation in order which is more convenient. I use universal G-code sender application to control the machine. Select the G-code, and then we can look at the G-code a little bit. So initial settings at the beginning. This is Z 5mm position, and then we have this first operation with the feed 100mm per second, then another operation with the 30mm per minute, and then the cut itself with the speed 10mm per minute. This one. Now we need to put the tool to the correct position to find the zero. But first we put the riser blade on this template. It is cutting oil, not the glue. Then we clamp it. The 0.3mm tool for the first operation. Now we need to put the correct zero position for the tool. So as I mentioned, this time I put it a little bit far down. Now we reset the XYZ for the machine and start the operation. Because speed is pretty slow, I made the video to play with the 4 or sometimes 10 times faster. You can notice that this is pretty deep cut because I put this Z position too far down. This white under the blank is the cardboard. That's why it's a little bit bended. Now I changed the tool to 0.5mm tool. Again, put the correct Z position, select the next operation G-code file and run it. Again, it cut it instantly through instead of several passes. Another operation for the hole. All this debris, it would be polished away with the sandpaper. Hole for the hour hand. Then I decided to cut contour of the hour hand first because tool is already next to the hour hand. Again, instead of several passes, and just cut through the blank and hand would fly away. Like this. Now we cut out the minute hand But here I adjusted the height, so it will be several passes. Anyway, we will not see those tabs. Final cut, but tabs supposed to be a little bit higher. Now hand is pretty rough cut, has many debris, so I use this 1500 grit sandpaper to clean it. This sandpaper or maybe debris leave some scratches which will be seen after polishing. This sandpaper is wet with the water. Now it looks cleaner, and sorry for this unfocused video. Here I use optical microscope with the magnification 100 maybe X. It's very convenient to use such modification to fix the shape. I fix it with the diamond file with the 600 grit. This works very well. The internal hole would be larger than the pinion on the watches, on the movement, because I will put the steel ring inside, like insert. This is small grinder, similar to Dremel, but smaller one. And I cut it with the diamond cutter. It's very convenient to use, and you can use it with a pretty high precision. Now I use polish and past and the same tool to polish it. Unfortunately, when you polish it, it also make sides a little bit rounded, but it has its nice advantage also with this reflection. And also you can see that when it will be polished, you would see some scratches, but it is not seen with the naked eye. I remind that this is actually 0.1 millimeter thick blank. You can see those scratches, but because of the large magnification. The specification for the movement, and this is an H35A movement from Seiko or Thai models. We can find all the dimensions for the hands and the internal holes, so we can figure out the diameter of pinions. This is 1.5 millimeter diameter and 0.89 millimeter diameter. I use stainless steel blank, 2 mm diameter, and this is central bore with the 1 mm end. So I roughly created this hole for 1 mm, which I will then extend to correct diameter with this cutting tool. This cutting tool I create from the 3 mm carbide blank. I can do any shape, so it's really convenient. I make it with the diamond disc rotating on the machine like a Dremel. Now I use many passes, cutting 0.02 millimeter depth. It's 10-15 passes for each diameter. Then we cut it away and polished it. This is the same sandpaper of 1500 grit. This is how it looks mounted on the our pinion. Then I decided to create some auxiliary tools with the diameter 1.5 and 0.88 millimeter. It is easier to use when you cut some internal diameter with a small hole, because it is required a very small measuring tool and many movement of the table. So this is 1.5 millimeter and 0.88 millimeter. So this is smaller hole. The drill bore is probably 0.6, which then need to be extended with the cutting tool. And if you are not such careful, sometimes this happens. But this is totally no problem, because I can create it again pretty quick. Now we turn away this external diameter for the minute hand. Very many passes with a small depth. It is pretty relaxing operation. The collet itself is ER11, as you can see. It's precise enough to work with and very affordable. A pretty straightforward routine. Cut it, measure, cut again, measure. Sorry for shaking, because I just any hit to the table move the entire camera setup, and with such magnifications pretty noticeable. I'll make this ring a little bit smaller, but then I figured it out that when I cut away this side, it actually damaged the internal hole, so it bent the material inside, so I need to clean it. I tried first with the diamond file, which didn't work, and then I just clean it with the tool, cutting tool. Very tiny depth for each path. Fortunately, this steel is pretty resilient, so it can bend and restore its shape. You can see I tried to fix the hole with the diamond file, didn't work, and then I clean it with the tool. Then I decided that I need to first create the rough hole, the smaller one, then the cut external diameters, maybe side, and then to clean it to the correct diameter next time. Then we cut it away. But first I decided to polish it a little bit, because it would be hard to polish sides when it is cut out. And the stainless steel polish it is very well. Tried to catch it with this box, but it just flew away. Then I polish it unnecessary parts with the sandpaper. This hand tool setter I created to make it easier to set the hands. It can be done manually, but with this tool it is more convenient. It has 3 different diameters. I actually lost this ring afterwards, and I never found it, and I had to create it again. Later on I also glue it with a super glue, the hands and the rings. So you can see it is not totally set at this moment, but then I set it more correctly. I also created afterwards this holder for polishing, so when you polish such details it would be not such rounded when you hold it with the fingers. So it's supposed to be more flat, as you can see it here. But then when I polish it with this tool, edges were a little bit rounded, but it has its advantages as well.